Engineering drawing conventions. Learning objectives. At the end of this topic, you will be able to know the standards in drawing sheet, explain the specifications of title block, describe lettering conventions, analyze the types and thicknesses of lines, know the overview of projections, understand the dimensions used in the drawing sheet. Outcomes. By the end of this topic, you will be able to achieve an understanding of the drawing standards, get clear view on range of engineering drawings and implement it efficiently, able to know the different views of an object. Engineering drawings conventions. This section will take you through understanding drawing sheet, title block, lettering convention, lines, projections and projected views. Convention on drawing sheet. Sizes. The size of the cut sheet range from A0 to A5. The width and height sizes of each sheet is in the ratio of 1 is to square root of 2. Width matches with height of the next larger size. A4 is most common. It is also easy to file in folders. Recommended sizes for drawing sheets are shown here. Note that each succeeding sheet is half size of the preceding sheet. Example, 2 pieces of A4 forms 1 piece of A3. This is the cut paper size. The largest paper, A0, has an area of 1 square meter. Selection of drawing sheet. Layout. The drawing sheet size is selected to accommodate the sectional and elevation views of part. Minimum number of views must be used to describe all geometric features of the part. Most of the drawing space is used for this. The drawing space available will be less than the cut size. The actual available drawing space will be further less. On the left, a margin of at least 20 mm is provided. It's usually marked out and provided on 3 other sides, either 5 or 10 mm. In many cases, a further 5 mm space is used along the left and top margin, locating scale or grid. Some space is taken away by the title block. Effective space may not be more than 185 by 240. Locating scale or grid. In many cases, a further 5 mm space is used along the left and top margin, locating scale or grid. On the left, the space available is marked out A, B, C. On the top, the space is marked out 1, 2, 3, 4. Thus, any region of the drawing can be identified through this grid system. Example, C7. This is of use while referring to features or dimensions on large drawings. Convention on folding of drawing sheet. Folding of the drawing sheet for preserving or documentation is equally important. Hard copies of drawings may have to be preserved in folders or cupboards, usually designed to hold A4 size. The recommended folding pattern is such that the title block is prominently visible in the folded drawing. Another consideration is that the left margin, 20 mm, is utilized for punching holes to hold the drawing in folder. The vertical folds are made first, followed by the horizontal folds, effectively turning each drawing size to the ultimate size of A4. Method of folding drawings for preservation. Folding of the drawing sheet for preserving or documentation is equally important. A3 size drawing sheet is folded by the following steps. The attempt is made such that the title block is visible after folding. First fold is along with the title block. Second fold is in the middle of the remaining half. Convention on drawing scales. Engineering part drawings are normally drawn to 1:1 scale. That is, 1 mm on drawing measures 1 mm on part. However, for very small parts, it is necessary to prepare the drawing on enlarging scale to provide clarity. For large-sized parts or assemblies, it is not feasible to make scale 1:1 drawings. Example, architectural drawings. Reducing scales 5:1 or 10:1 is followed. In most cases, the product drawing is made to a scale of 1:1. This allows direct measurement of a dimension possible if needed. However, for small parts or for better accuracy, it may be necessary to use an enlarging scale, example 2:1 or 5:1. For large-sized assemblies or objects, or for buildings, a reduced scale, such as 1:2 or 1:5 may be appropriate. Title block. The title block is normally placed on the right-hand bottom corner of the drawing sheet. The purpose of the title block is to uniquely identify the part. The title block carries descriptive information, in brief, such as part name, nomenclature or description, part number, material from which the part is made, post-manufacture protective finish, painting, plating, etc., and many legacy information relating to design, revision of design, etc. It is usual to have company logo. Standards recommend drawing sheets with title blocks, but many firms use their own designs, internal standards, with slight modifications to international standards. Typical title block is shown here. Origin. In the title block gives information regarding design team and implementation. Material. Field denotes the material written in abbreviated form. Weight, specified in the rightmost top corner, is important, mainly for large parts which may require special handling. Finish, post-manufacturing operation like painting, etc. Nomenclature, a technical description of the part, usually based on function. Example, clutch spring. Part number, important to assign distinctive number to track information. Number, arrived at on the basis of some protocol decided by project group or digital data handling group. Logo, optional if the firm wishes to announce their ownership. Projection, type of projection in notation form or scale of drawing. Revisions or alterations, important to know if one is the latest design or outdated. Conventions on title block. Drawings for an organization are usually made with uniform and standard title block. It may carry the organization's logo and details of IP rights on the drawing. The drawings or parts are numbered strictly according to some convention followed by the design department. This is essential for the purpose of control during stages of manufacture and use and later for legacy management. For example, this may be a 10-digit string made to certain protocol. The nomenclature of the part is displayed prominently next to the part number. The material used for the part, if it is an individual part, is indicated, usually in some abbreviated or commonly understood form. For example, round bar 516, steel C45, or CRCA sheet 1.6 mm thick. Another nearby column usually indicates briefly the heat treatment required on the part. For example, hardened and tempered, HRC 45 to 48. Usually, adjacent to the material specified post-manufacturing finish of the part or subassembly, such as surface coating, plating, painting, etc., is shown. As mentioned under projection, the title block announces the type of projection and the scale conforming to the drawing. Parts list. Parts list of an assembly, sometimes known as the Bill of Materials or BOM, is the complete list of parts identified through their descriptive names, part numbers, and quantity required per assembly. In the case of parts which are conforming to standards, the method of identification or nomenclature recommended in the standard is followed. For example, hexagonal socket head screw is XXX M10, zinc plated. Often part list is issued in the form of a drawing. Lettering convention. The technical drawings recommend certain styles and sizes of letters used for writing descriptive matters. These descriptions are required in the title block of the drawing and other locations such as material description, manufacturing instructions, parts list, etc. The essentials of this lettering convention are reproduced in the next slide. Sizing of letters is shown below. Lettering style. Uppercase letters. Small case letters are, numerical and special characters are, slanted letters are. Convention on drawing lines. The projected view of the part is created by various geometrical forms such as straight lines, arcs or circles, ellipse, polygon, spleen, etc. These geometrical forms can be created with line types which are continuous or discontinuous, dash type, dotted type, etc. Further, these may be thin or thick. AutoCAD allows you to choose various colors, and this helps to distinguish parts in complicated assemblies. While drawing a part, its outline is first made. Usually this is drawn by a continuous bold line. Some hidden features may be drawn with dashed line. Part's center line. Example for cylinder is presented as a thin chain line consisting of alternate long and small dashes drawn along its axis. Line forms used normally are full line, broken line, dotted line, freehand line, etc. Line thickness normally varies from 0.05 mm to 0.30 mm, but high thicknesses are also made especially for lettering purposes. Some important ones are shown below. Projection and views of the part. A projection is defined as the representation of an object on a two-dimensional plane. An object can have infinite number of views. The principal 6 views of an object is produced by the 6 mutually perpendicular plane of projection. If you imagine an object in a glass box with major surface of the object positioned so that they are parallel to the sides of the box, the 6 sides of the box become projection planes showing the 6 views. The 6 principal views of an object are front, top, left side, right side, bottom, and rear. In the oblique projection, the object is assumed to be placed with one face parallel to the plane of projection. Hence, that face appears in its true shape and size. There are 3 axes, a vertical, horizontal, and the third axis inclined to 45 degrees to the horizontal plane. In isometric view, the vertical edge of the solid right angle is shown by the vertical line. Other horizontal edges are inclined at 30 degrees to the horizontal plane. Though it conveys concept of the part well, it is difficult to specify dimensions as required for engineering purposes. Hence, for engineering drawings, orthographic projection is universal. In orthographic projection, projection planes are normal to each other. First angle projection. The BIS and ISO recommend use of first angle projection. The representative symbol for the projection as shown below is indicated in the title block. The object may be assumed to be situated in the first quadrant and then projected on the planes. This method of projection is known as first angle projection. Third angle projection. In countries following the FPS units, third angle projection is common. The representative symbol for the type of projection is usually displayed in the title block. The object may be assumed to be situated in the third quadrant and then projected on the planes. This method of projection is known as third angle projection. Conventional representation of materials and standard parts. For simplifying drawings, it is possible to represent commonly occurring or standard details through easily understood representations and notations. These details are 1. Common materials. 2. Common machine elements such as fasteners, gears, etc. This saves considerable repetitive work and drawing effort and time. Let us discuss briefly about the conventional representations of 1. Material and 2. Machine parts. As a variety of materials are used for machine components in engineering applications, it is preferable to have different conventions of section lining to differentiate between various materials. The recommended conventions for the materials are given here, in which the parts are sectioned to reveal hidden geometrical features. The hatching is patterning of section drawing with fine lines, as shown. This distinctively marks out one part from another. Hatching of these sections follows some pattern which are indicative of the type of material. Machine elements and parts. Standard parts, which have repetitive and laborious details such as screws, nuts, bolts, gears, knurled shafts, etc., can be drawn using simple geometrical representations as shown below. Screw thread. External screw thread. An external thread is a thread on the outside of a member, on the left drawn in traditional way and on the right conventional representation. Internal screw thread. An internal thread is a thread on the inside of a member. Example, as in a shaft end. The fastener is shown in the assembly. Example, as for cylinder and cylinder head. Machine parts. Holes on circular pitch. Flange with several bolt holes. Representative drawing shows a single hole and center lines of pitch holes. A squared end on a shaft. Example, for fitment of belt pulley. Bearings. Ball or roller bearings are shown on left, can be drawn on representative way as on right. Spleens on shaft are shown in simplified conventional representation on the right. Long shaft is shown in simplified conventional representation on the right with a break. Leaf springs. Leaf springs with eyes. On the left is the part drawing and to the right is part in conventional representation. Compression spring. Tension springs. Cylindrical parts with straight null or crossed null. Gears are important in machines to reduce gear reduction. Spur gears are most common types of gears. Bevel gears are the gears where the axes of the two shafts intersect. Worm wheel is a gear with a thread of a worm. Worm gear consisting of a spirally threaded shaft. Summary. Let's summarize the topic. The size of the cut sheet range from A0 to A5. The title block is normally placed on the right-hand bottom corner of the drawing sheet. The technical drawings recommend certain styles and sizes of letters used for writing descriptive matters. A projection is the representation of an object on a two-dimensional plane.